Hello, everyone, and thank you for joining us today for our HashiCorp Solutions Engineering Hangout, hosted by Joe Calandro. Today, we're going to talk about HashiCorp Consul Service on Azure. HCS on Azure enables a team to provision HashiCorp-managed console clusters directly through the Microsoft Azure portal. Joe is going to examine how HCS can connect services across a typical Azure hub and spoke network topology, including AKS clusters and VM-based applications. I also want to note that the Hangout is recorded and the recording will be made available after post-processing, usually within a day or two. I'll email it out to all of you. The demo will be about 20 minutes and then we'll allow up to 30 minutes afterward for questions. Please submit your questions through the demo via the Zoom portal and then we will answer them at the end. So with that, let's go ahead and get started. Take it away, Joe.
Thanks, Allison. Again, my name is Joe Calandro, Senior Solutions Engineer here at HashiCorp. Thanks for joining us today to talk about HashiCorp Consul Service on Azure, kind of specifically in hub and spoke network architectures. So I did want to kind of start off with a little bit of backstory about what Consul is and what challenges it's solving. Consul was really developed as a tool to solve challenges that have come with the need for more networking capability on east-west traffic flows versus north-south as microservice application architectures really become the new normal as we're decomposing monoliths and writing new applications in kind of cloud-native patterns. And this poses a bunch of different challenges. I mean, one, we're used to networking and firewalling by IP address in a known location that is our data center, and not having to deal with dynamic IP addresses across different clouds and other kind of operating and runtime environments. So the traditional kind of perimeter, kind of four walls of the castle security plan and even networking kind of strategy really breaks down with these new paradigms from a static and monolithic world to a cloud dynamic kind of microservice world. And my background is in networking, and I've heard this my entire career. And this is just a survey that we use in the third-party research space and of our own user base, that the network often gets blamed for slowness in being able to deploy our applications, but also it's always the first one to get the finger pointed at it when we do have an outage or downtime. And it takes a long time to provision kind of high trust networking zones with ACLs, firewall rules, complicated load balancing schemes. And it takes a long time to get our applications out the door. And it's really kind of become a hindrance to the DevOps movement and being able to deploy at the speed that the business demands. So enter Consul. Consul was created by HashiCorp to solve some of these challenges. It's a little known fact that Consul is actually the most downloaded tool from HashiCorp. It's really kind of solved the challenge of service-based networking in distributed application architectures. And it's kind of ubiquity as the service registry in that space is a testament to that. We're going to be kind of talking about two main use cases that Consul solves for today in Azure specifically. The one is service discovery and observability. So making sure that a microservice application can communicate with the other services that it's comprised of, and a service mesh to kind of secure the traffic flows between those services. Consul is really built on this key feature of a centralized service registry. And this is essentially just a key value store of service name and IP address. And it's this notion of kind of centralization of this registry that everything else we're going to talk about today kind of builds off of. It allows for services to be discovered and connected based on like a name or an identity and not an IP address. And right, we're just trying to decouple that so that we can kind of ease operations in networking and ease the workflow of our users trying to deploy applications into our enterprise environment. And what this centralization of the service registry enables is really something that's core to all of HashiCorp's tools, and that's a workflow-based approach, and one that's not dependent on technology. So with a centralized registry, our workflow for network operations in one cloud is the same as it is in another and in the data center. And it's kind of this notion that is common across HashiCorp's portfolio and very particular to Consul is that the kind of support model, how we're doing networking is now the same across our kind of disparate hybrid operating estate. And the kind of main first use case for Consul and now this centralized service registry that's been built is service discovery. And Consul is deployed in a client server model where the clients or agents are running alongside your applications and updating the Consul servers or that service registry with updates about new applications that are coming online. The health and availability of those applications is one thing that's also a happy accident of service registry and service discovery is now you have a centralized place to see the health of the services because that agent kind of knows if it's there and it's available to have traffic routed to it. So you get kind of some centralized visibility. One thing that doesn't get talked about enough is the ability to troubleshoot outages in your applications or networks, maybe before they get to a critical state where you're in a down state. You can see that maybe one of the web services is offline. And what's grown from that for Consul, and as microservices have become the kind of ubiquitous application development archetype, and as a result, Kubernetes has really grown to be the kind of de facto runtime and orchestrator for these kinds of architectures, is the need for a service mesh. So for several years now, Consul has included a service mesh as part of its capability. It's called Consul Connect, and it is based on a default Envoy control plane, but that's of course configurable to really be able to get visibility into the traffic between the different services that make up your application, and kind of in and out of that application, wherever those ingress and egress points are, but then also to be able to secure that because we control that data plane. We can enable mutual TLS and things like that to make sure that all the east-west traffic flows in your application are now encrypted with TLS. So that's kind of the primer on Consul and the kind of couple of main use cases we're going to be talking about today. Let's talk about the network architecture that is becoming more and more common as kind of cloud usage becomes the standard. And the one that I've run into a lot with my customer base is the hub and spoke architecture. This picture is right off of a reference architecture from the Azure website, documentation website, and is really kind of the standard way that companies at scale are being advised to deploy kind of a networking schema to how they're running applications in Azure. This has a couple of kind of key uses. The first is, you have a traditional kind of network segment approach where you might have a special segment for a DMZ or a specific application or an environment, right? You've got a dev spoke and a test spoke. And these spokes need access to, some sort of shared service, DNS, IPAM, Azure Directory, kind of directory services and Active Directory, NTP, kind of these kinds of services that lots of things in the network need access to. But that hub also not only houses shared services, but is the connectivity point back on premise. So this is where VPNs are terminating from the local data center or on-prem data center environment. That's where your express route can terminate to basically bridge over a controlled WAN type environment, your on-prem kind of traditional enterprise networking primitives to now the hub running in Azure. This kind of helps on the networking flow cost. In the cloud, you're charged on either ingress or egress into a given network segment. It becomes a cost saving mechanism to kind of centralize these services that get used, especially network kind of middleware-ish type services that get used by lots of different use cases, and all those different use cases live in their individual spokes and access that hub. So this is not like your typical kind of full mesh, right? Everything is just peered once to the hub. So it's really common though to see examples of why services might need to communicate between spokes. As we decompose monoliths and build new cloud native applications, it's becoming pretty clear that a lot of services are being reused. You might have an inventory service or something like that lots of different applications might need access to, or a common zone that's PCI compliant for handling payments and things like that you might have several applications that need to access. And a really common one is a DMZ. So one of those spokes might be for how your customers access those applications. And of course, those services are going to need kind of protected routes to the backend services that is providing that value to that customer. I've got a specific example where a client of mine is building a data platform, and it's composed of several off-the-shelf applications that need to work together. Those applications require their own Kubernetes clusters, and according to their network policy, get their own spoke. So for this stack to work well together, the different spokes need to be able to communicate with one another. So, some of these places come up where we need to network services between spokes, and Consul is really a great way to make that happen in an automated fashion, kind of with this centralized control plane and a service mesh where you can build secure connectivity via that kind of default TLS and a whitelist model for allowing only the desired east-west traffic between spokes to flow. And that's what we're gonna look at in the quick demo here and what we're gonna talk about. But first, let me explain kind of the other main topic of this lecture, which is the HashiCorp Consul Service on Azure. And this was just recently made generally available by HashiCorp, and it's a managed service offering of Consul, and it's natively available in Azure. We'll talk about how it's deployed here in just a second, but this is, like I said, the Consul architecture is client server, and this is HashiCorp managing the operations of the Consul servers. So you go to the Azure portal, select the HashiCorp Consul service, how many servers you want, and those are deployed into your Azure account. Those Consul servers are deployed at a production capacity, if desired, to the best practices that we've learned from deploying Consul in some of the largest environments in the world, tens and hundreds of thousands of services being managed by Consul. So it's a production-ready kind of deployment backed by an SLA from HashiCorp. And in Azure, resources that are both deployed as VMs and Kubernetes resources in AKS can be connected via Consul Connect and then managed by the control plane in HCS. And my last bullet here coming very soon is the ability to federate your HCS cluster to other Consul clusters running in other clouds or your on-prem data center to basically share that service registry and extend that Consul Connect service mesh between different cloud regions or data centers. At a high level, how HCS works is you're going to visit the Azure Marketplace and request a cluster. This then talks to a control plane that HashiCorp owns and manages, which then provisions a resource group, VNet, and the Consul servers themselves into the customer's account, which then can be peered with the hub and with spoke VNets for connectivity to the Consul clients that you'll provision on those VMs or in those AKS clusters. Now, kind of breaking down the two use cases we talked about in the introduction on service discovery, in particular here, HCS is going to talk to Consul agents running in one or more Kubernetes clusters, and specifically AKS clusters, to build that service registry of known services. Consul does this by connecting to AKS itself and exchanging the kube DNS information with the Consul service registry, kind of making services that are deployed there available in the service registry to be routed to. It's an analogous model to virtual machines, right? There's a Consul agent that runs on or next to an application VM that makes the Consul server and Consul service registry aware of the availability of that application running on a VM. And not all services can run in Kubernetes. This has become kind of very clear to the industry, is that Kubernetes doesn't solve the runtime challenges of all use cases, but we still have, especially data layers, kind of maybe monolithic applications that we need to talk to a scaled out front end that are going to run as virtual machines. And it's important to have a service registry, service discovery model that supports both of those. And I see this all the time is customers are starting to use Kubernetes and they need an elegant way to make the services running there be able to reach kind of database services that are running outside of that Kubernetes cluster. And a very similar picture is on the service mesh side. So service mesh is a kind of decoupled control plane and data plane at its kind of core definition. And the Consul Connect mesh by default uses an Envoy proxy that lives alongside services within a pod, the applications within a pod, also as another process running on a virtual machine that's hosting an application, or as a separate VM next to that application that's running a VM. And the service mesh enables you to route traffic kind of securely within a Kubernetes cluster or between two Kubernetes or more Kubernetes clusters. The same pattern is there on virtual machines. And of course, with Consul, it's not just about Kubernetes. It's not just about kind of traditional scaled out VM workloads, but that service mesh can also connect services in the same way between pods running in Kubernetes cluster and a virtual machine. So let's talk about the specific demo environment we're going to be looking at here. And I have a kind of sample application that has a web front end, and it's specifically for payments. And I have it deployed in Azure across kind of two spoke VNets, a front end and a back end. And these two VNets are peered to a hub. I call it kind of shared services VNet, where I have a virtual network gateway deployed, a vault server just for access to secrets, and a Bastion host that I'm using to kind of jump around in the environment. This would be typically, again, where VPN's express routes would terminate, is into this kind of shared services VNet. And that's what I'm kind of simulating here. I have the application deployed across two Kubernetes clusters, AKS clusters. There's one in each of those spokes, as well as the payments service kind of specifically deployed on a virtual machine in that front end spoke VNet. My access to the front side of the application is over a Kubernetes load balancer with a public Azure IP address. So I'm not going through the virtual network gateway. So we can think about this front end spoke VNet like we would a DMZ zone in a traditional network. So where I have applications exposed to the internet and then accessing kind of back-end services found in another segment, another spoke in Azure. In addition to the way the application is deployed, I also have HCS provisioned in my Azure account. It's got 3 console servers, and that VNet is peered to the hub as well as to the spokes for configuration of the service mesh that we're going to use to connect the services of this application. So it's demo time. Let me pop over to my demo screen. And I hope that that is large enough for everybody. But I have a environment here kind of provisioned in like a web UI. At HashiCorp, we use a platform called Instruct for these kinds of environments and demos. It can also be used for workshops. But I have my Kubernetes clusters deployed. This one is the backside, so it has the API, the cache layer, and the currency services. If I switch over to the front end AKS cluster, just to show you that I have that there, I can copy my commands correctly. And we do a kubectl git pods. We can see that the web service is running there as well. If right now I was to look at the application, I can see, and I should have stated that this application is really a dummy application, that all it does is kind of trace a traffic flow through the different tiers so that we can see what's connected and what's not. It uses both HTTP REST calls and gRPC calls for kind of different tiers of the application. Red is bad. That means I'm not being able to connect there. And if we curl the front side of the application, which I did earlier, we can see that I'm returning kind of a 500 down here, which is a bad thing, and 200 on the cache. So we should see 200s everywhere if this was working correctly. Let's talk about the console deployment kind of briefly. I'm logged in as a front end user here, but if we look at the nodes, which I don't have access to, just looking at the interface as my kind of default user, we can see there's a server node, 2 nodes. I have got kind of simple AKS clusters, each with 1 worker node in them each, and the payments server over here, which is just a VM running in Azure. So these are all the places that the console agent is running and reporting the health of services back to the console servers. I've got console divided up into several namespaces for kind of separation of duties for my application teams. The first is the front end, which has the web and payment services. That team is responsible for those two services, and the other is the backend namespace, which has the remaining three services of the application. They have different logins into console to configure the mesh the way that they need it to. They also have kind of different permissions to the AKS clusters where one can't get to the other, right? There's a clear separation of duties between what's happening in each one of those spokes. Now, if I look at the intentions, right, intentions are a way for console to whitelist the traffic flowing between the different services in the application. I have several of them set up already, which is why we're seeing some of the traffic flow through the application. But I'm not able to get to the kind of payments section of the app. So what we're going to do is log in as, again, the front end user and allow, create a new intention to allow the back-end API to get to the front-end payment service. So I'm going to log in now as the kind of front-end user. Which is done with an ACI token, or an ACL token, excuse me. If I can copy this secret, right? I read my token there. Just needed to refresh it to be able to relog back in. There we go. I'm actually using Vault on the backside to generate kind of dynamic tokens here so that they don't exist for very long. It's a part of the way that we securely define a service discovery kind of paradigm with console. It's with ACLs, or access control lists, for what services are allowed to register with console. And we use the same system for how we authenticate the users to the system to administer it. So if I create this service, it's going to start from the backend API. So I'm going to say that's in the backend namespace. It's the API service. And we're going to go to the payments service in the front end. We're going to allow this traffic. So as a user, I'm creating an intention in console, which has allowed these two services to communicate with one another. What console is doing is then going and configuring the Envoy proxies running alongside these two services. In this case, the payments service, which is running as a VM in Azure in the front end spoke, to a service running in AKS called API in the backend spoke. So if I hit save on that, so adding that next intention, I come over to the application and refresh this page. I see a lot less red, and I can see the application kind of flowing all the way down, web to the API, API to payments, and payments to currency. And similarly, if I curl back on the application, you can see I'm getting all 200s now and no 500s. And this is the response of the flow via gRPC as well as REST through the different tiers of the application, showing that in fact, I am allowing traffic between those two spokes via the Console Connect service mesh. So with that, I'm gonna kind of go back over to the slides, review the architecture just one more time of that demo, review what we just saw, and then wrap up with some Q&A time. So with this demonstration, we showed that in a Azure hub and spoke architecture, right, a front end kind of DMZ-like environment in the front end spoke, through a hub where shared services live and my connectivity back to the enterprise is, two services in a backend spoke that have kind of different requirements, rules, and around security for how those services are accessed, kind of different than the front end. Used the Consul Connect service mesh to register those services with Consul, and then apply intentions to whitelist that east-west traffic for this application within my network to allow a route for the traffic to flow and the application to perform. So wrapping up on HCS and kind of its core values, the Consul service in Azure now removes the onus of our customers to operate the servers that Consul and its shared registry run on. I'm able to connect kind of services across different runtime environments in Azure, and kind of very soon able to federate that service registry from HCS to other Consul clusters running in other clouds or on premise, being able to extend the mesh across those boundaries as well to securely route traffic between kind of services running across my hybrid cloud estate. And then lastly, HCS is like a native Azure experience. I request it through the Azure Marketplace. I have a managed Azure application in the dashboard that I can use to access the Consul interface if I want to. Everything is kind of provisioned in your account in Azure. And I wanted to leave this in the presentation so that everyone gets it with the recording for how to get started. There is a track on learn.hashicorp.com specifically for HCS, getting it deployed for the first time. And I did leave a link for where it's available in the Azure Marketplace. And if this is something that you need to explore more, like please reach out to HashiCorp and or Microsoft, who are both kind of willing and eager to speak to you about it. So with that, I'll kind of turn it over to questions.
Awesome. Thanks, Joe. We do have a few. First one, is the HCS Consul services planned to be available within Oracle Cloud? When? Any ETA?
Yeah, so HCS today is only available in Azure. So it's specifically called HashiCorp Consul Service on Azure. We announced at HashiConf EU in the spring a HashiCorp Cloud platform, which will have tenancy in as all of the major cloud providers. I don't specifically know about Oracle Cloud offhand. I know we're going to hit kind of the main three first. But Oracle Cloud is something HashiCorp has been committed to in the past. There's lots of good examples for how we've supported Oracle Cloud. But today, HCS only exists in Azure. In the future, the HashiCorp Cloud platform will offer a managed service offering of Consul, kind of available in the cloud of your choice. So that's how I'll leave that.
Okay. Is there any other way to authenticate with Consul other than ACL tokens?
So that is the way. You saw me using Vault to kind of automate that process. So I logged into Vault with a username and password. I could log into HashiCorp Vault in a myriad of different ways other than just username and password. But ACLs is the way to log into Consul. We have just added in the most recent version a single sign-on capability to Consul in addition to the ACL. It's kind of on top of the ACL model, so that you can log in other ways besides ACLs, specifically in the kind of OIDC model of Okta and those kinds of services for identity. So yes.
Great.
But there's a good integration story between different HashiCorp products by using Vault to kind of automate that process.
Okay. What is the latency effect of routing traffic through proxies?
There is a latency effect, but the one thing about Envoy is it's extremely performant. It can really blow other reverse proxies out of the water, like Nginx and HA proxies from a performance standpoint. It's also highly programmable, which is why it's become the kind of de facto data plane in service meshes. There is a latency hit. I would say it is quite small most of the time because that proxy is right there next to your application, whether it's a sidecar in your Kubernetes pod or another process on your application server. There's lots of good reports out there on performance in service mesh environments that I would advise you to Google and take a look. And it's going to be different dependent on the size instances you have, the kinds of applications and those things. But it's pretty negligible that I've seen.
Okay. How are the certs managed within MTLS automatically for expiry and refresh?
Yeah, so by default, Consul is the CA for those certificates. And that, of course, can be configured to work with other CAs for the certificate management. But by default, Consul is its own CA for the management of those certificates. Consul server. And in the demo, that was HCS.
Gotcha. And lastly, what is the deployment process for the HCS cluster?
Yeah, so I can kind of back up real quick to this slide, which kind of goes over that. The deployment process is requesting it from the HCS marketplace. You're going to provide it some configuration values, like what account you want it to use, the names of the VNets and resource groups that it's going to create and those kinds of things. It then makes those kind of infrastructure primitives, the resource group and the VNet and a couple of other things, NICs and things like that. It then deploys the Consul servers into that VNet and resource group. And then you're going to deploy the clients either via Helm chart to AKS or via Consul binary to VM and configure those to point back to the HCS servers. That is, of course, after peering the HCS VNet with your hub and spokes. That is detailed out pretty well in the Learn track that I link here as well. Kind of really gets you started on the deployment process.
Awesome. Thank you so much for your expertise on all those questions, Joe. As I mentioned in the beginning, the Hangout was recorded and we will make that recording available on our website after processing. We'll also send an email out to everyone who registered with that recording link. I hope you all enjoyed today's Hangout and have a better understanding of HCS on Azure. Thanks for hanging out with us today. And a big thank you to Joe for his time. That wraps things up for us. Have a great rest of your day.